Hello everyone and welcome to The Nest. This is our weekly newsletter where we try to share our aviation experiences with you and nurture the community that is building and constructing our kits and other kits. I've had lots of people come on and say that they really enjoy watching how wood airplanes are actually put together. So we're drawing in more people than just our Fisher community. So welcome. I just wanted to, take a minute to talk about, COVID and how it's affecting all of us. I miss going to the airport. I miss going out and seeing the guys there and having a coffee and going for a flight and, having our $100 hamburger and shooting the breeze about the breeze. Hopefully this forum, this ability to gather on a weekly basis is somehow helping stopgap that loss that we all feel, and hopefully soon we can all get back to those endeavors which fulfill us so much. This week I'm going to be speaking about a new rib design that we're working on for the Fisher Aria. I'll go through that a little bit. Today I'm going to also talk a little bit about the free plan sample challenge that I put out last week and let you know how positive that's been. We're also going to do an update on the Aria Early Bird special, and we're putting together another Early Bird special for the SF-1 Archon. So there's going to be, we're going to try to bring over multiple, 3 to 5 kits at a time. So we're going to be offering up some, a special in that regard. Lastly, again, we have Algy Yates who's coming in to talk about the Youngster Tail kit build. His videos have been very instructional and very well received by the community. I've gotten a number of comments on how helpful they are. So thank you again, Algy, for putting those together and letting us use them. So without ado, we're going to head right into the Aria wing rib design, and we'll review that. So here we go. This is Fisher Flying Products. I'm Dave Hartner. Welcome to The Nest. Our video newsletters provide weekly insight into building and flying our 15 wooden aircraft designs. Plini Motori of Italy is a gracious sponsor of our channel. Plini is the manufacturer of the Thor 250 DS. Cozy Carb Ice Prevention Systems is a proud sponsor of this channel as well. Please take the time to watch our videos to the end, as this assists us in the metrics that YouTube uses to rate our channel. Hit the like button if you feel that the content is worthy. We invite you to subscribe to our channel by clicking on the subscribe button and hitting the bell so that you are notified whenever we post our newsletters. Okay, we're going to dig into the Aria wing ribs now. The design goals, and I'm going to rip through this. There's a lot of stuff in this report that's given to us by our designer. So the design goals were to minimize labor input and to minimize material costs, create a strong FAR-23 aerobatic level wing, have the weight as close as possible to the original design, and we want to make it accurately reproducible. Front and rear edges of the would be beveled, and we want to use the same kind of cap strip width on the top where the skins are glued on. And so we looked at our materials. We've checked our spruce density. We've checked our birch plywood density as compared to it. And we know that the strength of the plywood is not as high as the actual directional, grain in the timber. And the acrylic plastic sheet for possibly gluing things together and using that so we don't have stuff stick together. So the original design study, we picked an airfoil, we analyzed it and found out that it was pretty close to the 35A212 riblet airfoil. It's not perfect to that, but we're trying to find out the exact one. We're whittling it down through that, so we'll know very shortly the exact airfoil that we'll be using. That allows us to be able to accurately predict the loads on the wing. And A few other things that we did too. The nose rib design for the Aria was very difficult to build from a builder standpoint, so we wanted to simplify that. And so we've gone, and our designer suggested we use something like the Whitman W10 tailwind nose rib design. So that's something that we're gonna incorporate in there, I think. So the original ribs were built up from 9 by 6 millimeter spruce 1 millimeter birch plywood gussets. We found that there's a bunch of different ways we can make a replacement rib that is easier to do and meets those design goals of reproducibility and cutting the labor. So we could take a routed truss, so 9 millimeter plywood, and just cut all the holes out of it, make a truss out of it. Works pretty good, adds about 3/4 pound per wing with all the ribs. The next one we could take, there's a disadvantage because of the plywood orientation and whatnot. It's not quite as strong as the built-up version. We could do a routed out plywood rib that leaves the center plies in place. This reduces the weight of the overall piece, but it still grows in weight of about a pound for each wing. The next one would be a three-piece rib that is glued together in a jig. And this is easily done on the CNC machine, and works pretty well. And yes, we do have to glue them up. There's some time involved, but we end up with a fairly light affair. And we've gone even further. This is the glue up area here. And then we've gone even further to have a peek at what would it look like if we actually routed out part of the inner web, and that seems to be the direction that we are going. In that we've found that yes, we do have a little bit of 0.84 pounds per wing increase, but with some changes that we're making, going from okume to birch plywood on the wing skins, we can go a little bit thinner on the wing skins and maintain the same strength, and we actually reduce the weight of the aircraft by a certain amount, and it's almost a net zero effect when you look at the rib change. So there's a nose rib, and then there's a main rib, and we go through that whole exercise again, talking about the design of that, and again we're leading us to where we're going to do a routed out center section and 2 outside sections. It leads to reproducibility. We can put 4 or 5 pieces of plywood on top of each other at the same time and cut them all at the same time, so it saves us a ton of time. There are some specific tank ribs and things like that we will have to be looking at and how they're designed, because big chunks of them get cut out for the wheels and for the fuel tanks. And then we've gone through and we've made a summary of weights, and again, professionally done, so that we know what we're talking about. We know how much weight we're gaining in certain areas, maybe reducing in other areas, and then that we move on to the testing. So we have to verify the manufacturability, we have to check the durability, we have to verify the weight, and we have to test the strength. So this is a diagram of how we might test the strength of the rib. Those weights can be lead, they can be water in buckets, they can be a bunch of different things, sandbags. And so we will go through a procedure to test the built-up rib to make sure that it meets the design goals for loads. And again, going on to the Aria wing skins, just basically, this is a drawing of the Falco, and shows how the wing ribs or the wing skins are laid out there, and the thickness of the birch plywood that is used on that aircraft. And so from there, we've been able to make extrapolations and found out that we were going to basically, from the okume, if we go to the birch and we change the thicknesses because of the increase in strength, that we actually lose weight on the airplane, and that allows to net zero with the wing rib increase in weight. So anyway, that's it for now for this portion. I'm going to now go into, and we'll talk a little bit about the challenge that I put up. Last week I was interested in getting more people to take our free plan snippets, and so I put a challenge out there that if you took one of the set of plans and we put everybody in the pot, in 2 weeks I was going to draw for a Fisher mug. And lo and behold, a box showed up today at my house, and I ordered a free mug for myself, a Fisher mug. And it says Algy'S and fresh cut grass. So anyway, we've got merch like this out in our web store. You know, I haven't got a lot there, but we're increasing it as we can. And this is one of the mugs that we're going to be giving away for that. So in the first week, we have gone from about, I would get between 10 and 15 people who took the free plans a week, and we doubled that. Plus, we went to, I think, 35 or 38. And so thank you for all of you out there who took a free plan sample and that are considering building one of our aircraft, and hopefully you win a mug. So I'll have that. I'll put that on the little table over here. Last week I was interested in getting more people to take our free plan snippets, and so I put a challenge out there that if you took one of the set of plans and we put everybody in the pot, in 2 weeks I was going to draw for a Fisher mug. And lo and behold, a box showed up today at my house, and I ordered a free mug for myself, a Fisher mug. And it says Algy'S and fresh cut grass. So anyway, we've got merch like this out in our web store. You know, I haven't got a lot there, but we're increasing it as we can. And this is one of the mugs that we're going to be giving away for that. So in the first week, we have gone from about, I would get between 10 and 15 people who took the free plans a week, and we doubled that. Plus, we went to, I think, 35 or 38. And so thank you for all of you out there who took a free plan sample and that are considering building one of our aircraft, and hopefully you win a mug. So I'll have that. I'll put that on the little table over here. And now on to Algy Yates, who's going to continue with his Youngster Tail kit build.
In this video, I finish off rounding off the leading edge of the horizontal stabilizer, trim the ends, and then crack on with creating the elevator bows and laminating them up using a slightly different technique to the one used for the leading edge. This isn't an instructional video, this is just how I do things. If you get any hints or tips from it, that's all the better. So let's crack on and look at the video. You can see I've drawn a centre line on the leading edge here, and if I've got a round over bit which has got a radius of half the thickness of the material, but the roller is sitting below that centre line, so when I do the second cut on the other side, it would be sitting into the bit that's already been cut. So what I'll do is I'll set this up so that it's about a 1/16 of an inch above that centre line, and we'll still get quite a good round over, which I'll finish off with sanding. You can see that the stabiliser is clamped down while I'm doing the routing, and that the excess of the laminations is there so that the router will not go around the end onto the spar section. Right, so just to round this off a bit more, where the router wasn't as low as it could be because of the fact it would go over the centre line, I'm now going to sand the edges here at a shallower angle, concentrating on the plywood. An angle like that, and be able to tell that you're doing it evenly along by keeping the lines parallel on the ply itself as you go around the corners, like that. And that just gives a nicer round over for the start off with. Now with that shallowly sanded at an angle like that with the block, it's now time to round things over. So I'm just using 180. Make sure you sort of break it so that it rolls nice and easily. Just a thin strip of emery, and it's a case of don't put too much tension on. You're just wanting to round the edge. So. Bit more time spent where the plywood is. Hardly any tension at all. Just enough to get it to go around the edge like that. And that will carry on from there. Just for final round over, I've got a high density foam piece which I've dremeled with a round tool to produce a channel to fit on there. Just put a piece of, I'm using 180 grit, wet and dry. Just get that formed around the leading edge bit, and then there we go. We can do a nice finished sand to smooth out that radius. Right, so I just want to finish off this end here where I've just cut off the laminations with a tenon saw. This is inset the thickness of the friction material I have here, and the block here has got a section where there isn't any friction material, which is the thickness of the MDF. It's all set at 90 degrees, so by holding the block at 90 degrees like this, I can run the sanding across the joint. It will make it absolutely perpendicular and straight. There's no chance of curving it. In point of fact, I cut that really fairly accurately. It's just a little bit there still. There we go, that's the end of the joint. Now this section here will end up getting sanded a bit to match the elevators once the elevators are complete, but hopefully it shouldn't take too much. I'm expecting about maybe 1/8 of an inch, maybe slightly less. Okay, so I'm going to laminate this up slightly differently to the way I did the leading edge of the horizontal stabilizer. I've put on a really strong tape. It's clear, so it won't show very well on the camera, along the what will be the outer face of the outer laminate. I've selected the wood, or sorted the wood rather, so that the straightest grain, ones with the least runouts going to one side or the other, are going to be used on the faces, and the ones with a little bit more runout, but still well within acceptable levels, are going to be sandwiched in the centre. And also the way the runouts are going to go, they'll be slightly diagonal. So if it's running out like this piece here, it's running very slightly out towards this side, it'll be next to a piece that's running out slightly towards that side, so that way that they're interlinked. As you can see down here, hopefully if I lower the camera, you can see I've got a lot more blocks involved for this radius, and what I'll be doing is I'll be using this type of clamp just to slowly pull them incrementally into position, the laminates into position before I clamp them, rather than just trying to force it into one, pushing it into one place and using the normal clamps. If I did that, with this being so close to the maximum tightness of radius for the strip wood, we'd end up with it cracking and breaking. Here I am applying the resin. The same as I did on the leading edge, I'm only applying it to one face of the laminate. trying to incrementally pull the laminations into the form there. Not clamping too tightly, we don't want to expel all the glue, but we do need to hold into that radius which is going to try and straighten out of. And here I'm just tapping down with the hammer to make sure the laminations are at the same height. As you have seen from the time lapse, when I was doing the lamination, it was hard to try. I was trying to manipulate 3 clamps, so 2 clamps would be used on the next one. Lesson learned, but we've got success. I'm just going to take these clamps out of the way, and I'm going to use the same blocks and jig for doing my second one. That way I know I've got 2 identical, as near as identical as we can have, bows, laminations going. It saves me having to put even more holes in my workbench. We've got a good coat of resin going through. There's not much in the way of any steps there on the laminations, so that'll sand easily. And if I peel this tape, which is what we put onto the leading edge there, get that off. We've got, and that's really seemed to work well, as it has done in the past, to make sure that there's been no splintering out at all of fibres. Absolutely no sign of any sort of splinter or anything like that. And there we have a bow ready to go. I'll sand that down whilst the other one is being laid up. This one's been sanded. I've just taken out the next one, which will need to be sanded, and if we do a comparison check on there, it's really a good match, an excellent match. No difference at all that I can see. One thing I didn't mention when I took out the bows is I put a little mark on there that signifies the point there, so that when I put it back into position, I can just put it right back into where it should go. This concludes the video for now. The next video I will be putting the tail. I'll put the tail plane together, but I won't be showing that in great detail. It'll mainly be time lapse because it's similar to the horizontal stabilizer side, but I'll also be talking to you about a couple of decisions I've made with regards to the tailplane elevator specifically. So see you in the next video. Bye for now.
Thanks again for watching. We try hard to bring you interesting content each week. To help us out, please like and share our videos if you feel the content is worthy. To receive the latest info from Fisher Flying Products, click the subscribe button and ring the bell. See you next time in the nest.